Imagine a future where teleportation is possible. In the time it takes to make a long-distance phone call, you could be there.
If an alien invasion force was hovering overhead, or an asteroid was hurtling towards the planet, you could instantly beam yourself out of danger. Cars would be obsolete. Airline food, a bad memory. Even NASA engineers could put their feet up. Who needs expensive rockets when you could simply teleport? I could zap to Paris on a whim, swing by Tokyo on the way home, and take in the view from the moon if I felt like it. A teleportation system would change everything.
And I'm going to show you how to build one.
I want my design to be the ultimate sci-fi teleporter. First, I need a very clear design spec. Who better to ask than the sci-fi fans themselves?
A teleporter should be able to just put you anywhere.
Like a doorway that you're walking from one location to another.
You would be able to step off of the platform here on Earth, and suddenly you're now climbing the mountains of Mars.
My teleporter needs to provide instant travel to anywhere over any distance. I guess Mars could become a hot holiday destination.
For those of us without the power to jump through space-time, teleportation is going to require some pretty serious equipment.
My system needs to be fast, accurate, and 100% painless. It should be able to beam you anywhere, instantly.
It has to be totally reliable. Who wants to teleport if there's a risk of losing half your body in transit?
My teleporter should be able to transport anything. A person, a train, the Empire State Building, if it fits into the machine.
Let's say I want to send this sculpture to the International Space Station.
According to the lore of science fiction, I've got two options. I could break it down to its atoms and somehow try to transport those, like in the movie The Fly. But I think Star Trek had a better approach. Convert it into data, a bit like a set of instructions, and beam those up.
This may sound pretty simple, but it helps to bring teleportation one step closer to reality.
Rather than transport the atoms, I transport the instructions. And providing that there are plenty of atoms at its destination, it can be reassembled. Data contains no matter. So it would be a lot easier to beam around the universe than solid atoms. This is definitely the best option for my design. And the crazy thing is, I've been beaten to it. Scientists here at the Joint Quantum Institute have achieved the impossible.
That event, the rising edge or falling edge, tells us that the teleportation is done.
Chris Monroe and his team have already managed to teleport atomic data.
So we're actually witnessing teleportation right there and right there.
That's right. That's happened a few seconds ago.
So teleportation really is possible. This is proof of principle. Chris and his team have teleported atoms using nothing but a mysterious connection called quantum entanglement.
Quantum entanglement is a link that allows you to transfer information. It's very much like a cable, but the cable's not there.
I think this invisible cable could be the basis for my teleportation system. In this experiment, two metal atoms are enclosed in separate containers. We start with two laser pulses that vibrate exactly in sync. Those two pulses in turn hit two atoms simultaneously, so the atoms too are now vibrating in sync. This somehow creates an invisible connection between the two atoms.
We form the link using light. But after the light is gone, the entanglement is still there. So what makes the entanglement? There's not a good answer, because there's nothing that makes the entanglement. It just is.
It's so weird that even Einstein had problems understanding what was going on. He called it spooky action at a distance.
Imagine all the information in atom A magically teleported across the room to atom B, creating an exact copy of the original. All that we used was this ghost-like bond between two atoms called quantum entanglement.
It actually blows my mind. Just imagine, the universe is crisscrossed with trillions of these weird wires, each one carrying messages between distant atoms.
I'd like 2 plain hot dogs, please.
Quantum entanglement is on the very edge of our understanding of the universe, but it seems to work like this. If I bite into this hot dog, then I know with 100% certainty that nothing will happen to that hot dog. However, if these hot dogs were atoms, then the laws of quantum physics apply. And in the quantum world, things get really, really weird. Let's say these atoms could be in one of 2 quantum states, mustard or ketchup. In the quantum world, until the moment I try to find out what state the atom is in, it's constantly switching between the 2. It's only when I look closely that the atom picks which one it will become. But here's what's even stranger. If I manage to entangle the 2 atoms, then the moment one hot dog becomes mustard, its partner, even if it's at the other end of the universe, mysteriously becomes ketchup. If the first hot dog picks ketchup, then its partner becomes mustard. This invisible entanglement link could be the key to my teleporter design. It's the pipeline through which I can transmit data. How can the information of one atom move to another atom across light years of space? What is this invisible bond made of? The short answer is, we have no idea. Let's say I wanted to teleport an atom from here to Tokyo using quantum entanglement. I start with 2 atoms that are vibrating exactly in sync, so they become entangled. Then I separate them, putting one in New York and the other in Tokyo. They would form an invisible cable along which data about my atom could travel. Next, I would take the entangled atom in New York and turn it into an exact copy of my atom. Because of the weird laws of quantum physics, the atom in Tokyo instantly becomes a mirror image of my atom in New York. If I make a measurement of my New York atom and find out it's red, then I know that the Tokyo atom is yellow. So by simply turning the atom in Tokyo into its opposite, I find that it's now identical to my atom back in New York. Faster than you can say energize, all the information in my atom in New York has teleported across the planet to Tokyo. So in theory, teleporting a human should simply be a question of scaling things up. But I would need an entangled atom for every atom in my body. But that's 2 whole bodies worth of atoms. I need a pile at every conceivable starting point and destination. And entangling atoms is not exactly easy. It takes the team at the Joint Quantum Institute in Maryland 45 million attempts to entangle just 2 atoms. So it would be unbelievably complex to build a machine capable of entangling every atom in a human body, every single time you wanted to teleport. There are more atoms in a human body than there are stars in the visible universe. So to teleport a human being using quantum entanglement, that gives me a headache. Quantum teleportation transfers information rather than solid atoms. I still think that's the key to pulling this off. But you know, I simply don't trust quantum entanglement to teleport the atoms of my body because it's so bizarre and poorly understood. To make teleportation a reality, I want something reliable, something tried and true, rather than such a strange phenomenon of the quantum world. I need to find a radical new way to teleport information.